Welcome to the video. So this is the data science subject and the first internal of the data science subject, and this is the first internal paper, and we will going to solve this. I will going to explain the solution for this first internal test. Okay, so let's read out the question first. Scenario: following table presents a training set D, okay, of class labeled tuples randomly selected from the all electronics customer database. The class labeled attributes by computer has two distinct values, namely yes and no. Okay, therefore there are two distinct classes, that is m is equals to 2. If class C1 correspond to yes and class C2 correspond to no, there are 9 tuples of class yes and 5 tuples of class no. A root node n can be created for the tuple in D. Now, related to this paragraph, we have three questions and we have the table here. Okay, so this paragraph is explaining this table only here. Okay, so find the splitting criteria. What question one says? Find the splitting criterion for this tuples using computation of information gain of each attribute. Now we have to take out the computation of information gain. We have to take out the information gain for this each attribute, and we will need to find out the entropy here to find out the information gain. Okay, now find the splitting criteria for this tuples using Gini index of each attribute. Construct the decision tree. Now we also have to construct the decision tree and find the splitting criteria for this tuples using Gini. Now we also have to find out the splitting criteria of this tuples through the Gini index. Okay, so Gini index of the each attributes. Okay, so what we have to do is, in information gain, what we see, the more attribute information we will get, we will make it a root node. Okay, and in Gini index is also called as impurity Gini. Okay, so the least Gini index we will choose as the in Gini index form. We will, when we use the Gini index method to form a decision tree, we will choose the मोस्टली मतलब लीस्ट वाला हम लोग चूज करेंगे. विल चूज द लीस्ट गिनी इंडेक्स बिकॉज इट कंटेन्स द लीस्ट इम्प्योरिटी. सो वी विल चूज द लीस्ट गिनी इंडेक्स फॉर making the root. Okay, so class label training tuples from this. So yeah, this is the table we have given. So this paragraph is explaining this table only, and these are some questions. And question 3 I haven't read. Construct decision tree of both the cases, question 1 and question 2, and compare the generated rules. Okay, so this question is whole about constructing the decision tree. Okay, so how we will going to construct the decision tree. So two types in by the two types we will construct the decision tree for this table. One will be using the information gain and entropy approach, and second will be the Gini index approach. Okay, so this is all about the first internal question. Now we will going to see the solution for this question. So here we are with our solution. So the problem definition: build a decision tree using ID3 algorithm for the given training data in the table by computer data, and predict the class of the following examples. Age is less than or equals to 30. Income is equals to medium. Student is equals to yes, and credit ratings is equals to fair. So the concept here, less than and equals to, is similar here in the question to youth, middle, senior, middle, youth. Okay, so the concept here, they have taken the less than or equals to, then just it's just similar to the table in the question. Okay, so the concept here is different because they have taken the less than equals to 30, so they have considered the age. Okay, to show the youth, to show the senior, okay, to show the young. So it's like that. Now we will see the solution. Okay, first check with the attributes provides the highest information gain. In order to split the training set based on that attributes, we need to calculate the expected information to classify the set of the entropy of each attribute. Now I'm suggesting you this YouTube video if you really want to understand this very nicely. So if you are not getting the video by me, if you're not getting the explanation, so you can also watch this video. Okay, so this is what its name. the channel name, and the title. So by typing the title in channel name, you will get the video there. Okay, so let's see the information. The information gain is the mutual information minus the entropy. Okay, the mutual information of the two classes will be the entropy as E9 comma 5 is equals to minus 9 comma 14 log 2 9 comma 14 minus 5 comma 14 log 2 5 divided by 14 is equals to 0.94. Now consider the age attribute. Okay, now we're going to take the age, income, and age, income, student, credit rating by no, we are not taking by computers. Okay, so we will going to take this 1 2 3 4 4 attributes. Okay, income attribute, student attribute, okay, and credit rating attribute. Okay, and yeah, these three attributes, and by comparing it from the Bayes computer, we will consider it, we will going to calculate its entropy and information, overall information gain. Okay, so now consider age attribute. So considering the age attribute, for age we have three values. Age is less than equals to 30, 2 years and 3 no's, age 31 40, 4 years and 0 no's, and age is greater than 40, 3 years and 2 no's we have. Okay, entropy age is equals to 5 by 14 minus 2 comma 5 log 2 in brackets 2 divided by 5 minus 3 comma 5 log 2 in brackets 3 divided by 5 plus 4 divided by 14 0 plus 5 divided by 14 minus 3 divided by 5 log 2, and this is how we will going to calculate the entropy, and this will be the entropy, and this is the gain. Okay, next consider income attributes. Income attributes, the gain will be this. Okay, and the entropy will be this. Next consider student attribute. So student attributes, in student attribute the gain will be this. Okay, finally consider credit rating attributes. So for credit rating we have two values: credit rating fair 6 yes and 2 no's, and credit rating excellent 3 yes and 3 no's. Entropy credit ratings 8 divided by 14. Okay, and by doing this we will going to get this entropy, and we will gonna gain credit ratings का gain मिल जाएगा 0.49. Since age has the highest information gain, we start splitting the data set using the age attribute. Okay, so I have already told you the highest information gain will be set as a attribute. Okay, as a node root. So the data set age attribute, splitting data set, again we start splitting the data set using the age attribute. So we are taking it as a root node and splitting in by condition of this age. Okay, now here less than equals 30, greater than 40. Okay, now here income, student, credit, class, and the age attribute will be removed because we have already chosen the age attribute as a root node. Okay, so the third one is 31 40, 31 to 40. Okay, now here this three we got the three age attributes. Okay, now we have splitted in the form in with respect to the age. Okay, so we got this three tables. Now, since all records under the branch age are of yes, so here all you can see the ages are yes. Okay, so yes, we can replace the leaf with the yes. So yeah, class is equals to yes. Okay, now here they are different, like yes yes no no yes no. Okay, so we have to solve this. Now build the decision tree for the left subtree. The same process of splitting has to happen for the two remaining branches. Okay, now both the branches will going through the same methods. Okay, what we are doing for the for take outing this age. Okay, so the same method it will going to follow. For branch age equals to age is less than equals to 30, we still have to use income, student, ratings, which one should be used to split the partition, the mutual information. So this is the 0.64 is the mutual information. For income we have yes and no's, and entropy will be 0.4, and yeah, now the gain of this income will be 0.57, this will be 0.97, and this is the, we can then safely split on attribute student without checking the other attributes, since the information gain is maximized. Okay, now age student Now on the student basis of the student, we have this table and this table, and on the age this side we have this whole table. We haven't followed the matters on this, we have followed on this, that's why we have yes and no on these two tables of this. Okay, student of student. Since these two new branches are from distinct classes, we make them into leaf nodes which their respective class has label. Okay, so this we can leaf node. Okay, and this is what we got of left side. Student class yes, class no, yes no. Okay, lesser than or equals to 30. Yeah, this is yes. And now we have to solve for this part. Okay, now for this part, now build the decision tree for right left subtree. So we have to build the decision tree for left subtree, right left subtree. This is the right. Okay, now the mutual information entropy is 0.97. For income we have two values, income yes and no, one yes and one no, two yes and one no. Okay, so entropy will be 0.95, gain will be 0.02. For student we have 0.95 entropy and 0.02 gain. So for credit ratings we have two values, credit rating fair 3 yes 0 no's and 0 yes and 2 no's. Entropy will be 0, gain will be 0.97. Okay, if there is 0 in any data set comparing the yes and no, then the entropy will be directly 0. Okay, you don't need to calculate the entropy. Here is the very important information I'm giving you, that if there is a 0 in comparing the two data that like 3 yes and 0 no's while comparing the attributes data, so if there is a 0, okay, then you can directly write the entropy will be 0. But in this case, and in this case if it is 0, then you can directly write the 0.97. okay, like this. So this will reduce your calculation. Now we then split based on their credit ratings. This is splits given partitions each with records from the same class. So age student class no, here all we got the decision tree. Now example, age is less than income, medium, student yes, credit ratings fair. Follow branches, age less than is equals to 30, then student yes, we predict class is equals to yes. Okay, bias computer is equals to yes. Summary, what we will get, this article discuss ID3 algorithm, decision tree, solve example, machine learning if you like. Okay, so this is whole we will going to get the tree from the question. So this is all about the internal first. So this is what they are asking in the first internal. Okay, so this is all about the data science of first internal. This is the decision tree they are asking for. Okay, just we have taken this in the place of youth and in the place of youth, senior, young. So okay, so this is the similar data, this is similar thing they're asking in the first internal. Thank you very much for watching the video, and yeah, this is the first internal solution video, and we will going to move towards the other solution videos like internal second, third and fourth in the next videos. Thank you very much for watching the video.